Hey guys, it's Miss Johnson, and I'm here to bring you our notes for the first lesson of Chapter 4. We're in 4.1. In Chapter 4, we start talking about how to collect data for a survey or an experiment. So we're going to learn lots of different ways of sampling to pull subjects for the data we want to collect. So before we start talking about those sampling methods, we just need a couple of definitions. We've said a lot of these words since the beginning of the year, but probably never really defined them, so we're going to actually define them today. So the first one is population. The population in a study is the entire group of individuals that we want information about. So if I was going to pull a sample of students from Farmington High School, my population would be all students from Farmington High School. When you perform a census is a type of data collection where you collect data from every single person in the population. If you're able to collect data from every single person in the population, that's called a census. It's really, really hard to get a census. It's very rare that you're going to get a response from every single person in your population. You've heard of collecting census data in the country before. Even they call it a census because they're trying to poll or they're trying to survey every single individual that lives in the country. But even that census, it's called a census, there's no way that it collects data from literally every single person that lives in this country. But that's what a census is. A census is when you can collect data from every single person or every single individual in the population. Sometimes it's not people, sometimes it's animal or whatever else. But when you collect data on every single individual in the population, that's a census. Typically what we are doing is we take a sample from the population. So a sample is a subset of individuals in the population that we actually collect the data on. So when we pull a sample of people, we get a sample here. The sample comes from the population. If we collect our data in an appropriate way, and it's from a representative sample, so we have, we're doing it with no bias and things like that, then we can use that sample to make inference or to make kind of assumptions or guesses, educated guesses, if you will, about the whole population. So you can collect data from a sample, and if you've gathered your sample in the right way, you can use that data to make inference or make judgment calls basically about the whole population. So the idea of a sample survey, we often draw conclusions about a whole population on the basis of a sample. Choosing a sample from a large varied population is not that easy. A sample survey is a study that collects data from a sample that is chosen to represent a specific population. So we have to decide what our population is, then we have to decide the data we want to collect, and then we decide how to choose the sample. And you have to be really careful about how you pick your sample. I can't just walk down to the cafeteria and grab the first 5 people that I see. That might not be representative. Am I picking all from a freshman lunch? So then I'm only getting freshmen. Am I seeing only students that go eat lunch in the cafeteria? I don't know. So you have to be really, really careful about how you collect your individuals for your sample. So along those same lines, there's a lot of ways to sample badly. So if you choose individuals from a population who are easy to reach, that's called a convenience sample. One kind of clear example of a convenience sample is if you stand outside a grocery store on, like, say I'm going to the Cub Foods on Dot and Cedar, and I stand outside the Cub Foods and I take the next 10 people that walk into the Cub Foods, and I use them as my sample, and I'm going to call that my sample for the entire population of Lakeville. Okay, does the Cub Foods exist in Lakeville? Yeah, sure, totally does. Is that representative of the entire population of Lakeville? No, absolutely not. It was convenient. All I had to do was stand there. I didn't have to do any work. I just stood there and grabbed the next 10 people I saw. However, what time of the day was I shopping? And where was I located in Lakeville? So did I get a cross-section of everybody who lives in Lakeville, or did I only get a section of people who live close to that Cub Foods? So I can sample conveniently and easily, but that usually doesn't give you a very good depiction of the entire population. It says, caution, convenient samples often produces unrepresentative data. Yep, that's very true. So the design of the statistical study shows bias if it is very likely to underestimate or very likely to overestimate the value you want to know. Bias is not just bad luck in one sample. Bias is a result of sampling badly. Bias is a result of not going through the proper channels or the proper methods to collect a good wide sample. So then another method of sampling badly, and this is something that's done all the time in our country. So convenient sampling will almost always result in bias, but so will some other sampling methods. One of them is voluntary response sampling. How many times have you left a store or a gas station or anything, and at the bottom of the receipt that you're handed, it says, go take our survey for a chance to win a $100 gift card, or whatever it may be. That happens all the time. That is voluntary response. And if you're like me, I typically take those receipts and throw them right away, because I usually don't take the time to go through and do those things. I don't think my odds of winning are very good, and I don't always have a lot of time to do that. There's other things going on in my life. So that's voluntary response, and I don't often participate. So that doesn't help the people who are trying to collect data from a sample. So other methods of, so voluntary response sampling is when you allow the people to choose to be in the sample by responding to a general invitation. You're not recruiting them and then, for lack of a better word, forcing them to be in the study. You know, if you recruit somebody and they know what they have to do to be in the study beforehand, then you can do things a little bit more accurately, because you know you're going to control their responses and you know you're going to get responses from them. But if you just throw a whole bunch out there and hope you get some back, that's voluntary response. That's not a super awesome way. However, that is probably the easiest way for us to collect data without having to force people into something that they may not want to do. So internet polls, call-ins, text-in, write-in polls, those are all voluntary response sampling. People who self-select to participate in such surveys are usually not representative of some larger population of interest. So then how to sample well. So the most common sampling method that you will hear about and you read about is called an SRS. It's a simple random sample. The key word there is random. So random sampling is what involves using chance to determine which members of a population are included in the sample. So you have to take some sort of outside tool or resource to generate your random individuals. Oftentimes that's a random number generator. We have a random number generator on our calculators. We can use that to collect our sample, to decide who's going to participate in our survey or our experiment if we're doing an experiment. So a simple random sample, or SRS, you're going to hear SRS a lot. An SRS of size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. So every single group of individuals, I could make tons and tons and tons of different groups of individuals, and they all have an equal chance of being selected, because I'm selecting them in a random way. So that's a simple random sample. How to choose an SRS. So the first thing that you do is you have to label each individual. So each member of the population gets a numerical value, and then you're going to randomize. You're going to read consecutive groups of digits of the appropriate length from left to right across table D. So table D is in the back of your book. If you flip to the back of your book where we had those tables, you're going to see table D. Table A is the normal distribution table, a normal probability table, and then table B was t-distribution, which we're going to get to way later. There's table C is chi-square, which we're going to get to later, and then table D you get to random digits. So in table D, you see a whole bunch of rows of digits, and you can pick a particular line value to start at, and then you just read across and look for those groups of digits, okay? You ignore any group of digits that wasn't used as a label. So for example, if you're labeling 20 people and you label them 01 through 20, if you come across a group of digits in the random table that is 65, 65 is not part of your population. So you just skip over that and go to the next group of digits, okay? So we select and choose individuals that correspond to the randomly selected integers. All right, so we're going to use line 130 of table D, and we're going to pick an SRS of 4 hotels. So we've got 28 hotels here that are named, all the way from 01 up to 28. So what it says is use line 130. So in table D, on the left-hand side, you can see that there's some line numbers marked for you. And that just helps you find your position a lot easier because this is a really big table of a lot of numbers. So when I go to line 130, I know that I'm looking at groups of 2 because all of my digits are groups of 2. So I have 01, 02, 03, all the way up to 27 and 28. Okay, so I'm looking for groups of 2, and they go from 01 to 28, and I want the first 4 hotels. Okay, so the first group of digits that I see on line 130 is 69. That is not in our group. Our group goes from 1 to 28, so I'm going to skip over that one. The next group of 2 digits that I see is 05. So 05 is going to be the first in my sample. So that line that I'm looking at says 69051. So this one I had to throw out because that's not in my sample. This is one I'm going to use, okay? Then I have the 1, and across in the next group, I see 64817. So this 1 can go with this 6 and make a 16, and that is in our group. So we're going to pick this 16 right here. So there's our second sample. Sorry, my rogue pen mark there. Then the next group is 48. 48's not in my sample list, so I'm not going to pick that one. Then the next group is 17. 17 is in my sample list, so I am going to pick that one. So I know I want this Ramada. Then I go across to the next group of 5 digits, and I see 87174. 87174. So 87 is not in my list. That's too high, so I'm going to cross that out. The next one that I see is 17. Now, I already chose 17. So normally I would say, yeah, 17's in my list, so I'll pick it. But since I already picked it over here, I'm tossing that one out because I can't choose the same subject again. Then I have a 4, and whatever is going to come after it is going to get crossed out because I don't have anything in the 40s. So it was a 0. 09517. So I still need one more, right? I have 3. Yep, okay. So this 4 and the 0 are out. 95 is out. And look, hey, there's 17 again, out. I'm going to keep going. The next one is 8453. 84, 53, and 4. So this is out, this is out. I need to go to the next one. I have 0, 6, 4, 8, 9. So this 4 went with that 0, that's out. 64, 89. I got to go to the next one. Super fun, huh? 87, 2, 0, and 1. 87 is out, and check this out. Boom, 20. So there's the last one in my random sample. So that's how we use Table D. Table D is when you just read across a particular line. Sometimes you're told what line to read. A lot of times you just pick a line yourself. Just pick one at random and read across to pick your sample, however it may be. Sometimes your things are 3 digits long. Sometimes you'll have like over 100, so you'll have to do 001 all the way up to like whatever your hundreds might be. And then you're looking at groups of 3 digits as you go across. Okay, so it just depends on what you're looking at, how much data you have, what your population is. So anyways, those are our 4 samples. We would use the number 5, number 16, number 17, and number 20. If I was writing this out for an AP exam, I would also, to give it context, I would put the names of the hotels with it. So choosing an SRS, we talked about this. You give each individual in the population a distinct numerical label from 1 to n, where n is the number of individuals in the different population. Then you randomize, use a random number generator to obtain n different integers from 1 to capital N, which is your last number, where n is the sample size. And then you choose the individuals that correspond to those randomly selected integers. So just like everything else in this class, which is so amazing and awesome, we have a way of doing this on our calculator. So great. So here's some directions to doing this on your calculator. We have a random number generator. It's called randint. It's a random integer. So if I go to stat and then edit and then L1, this is to put it in your stat editor. Okay, so if you want to create a random list of a random list of integers to put in your stat editor, this is what you would do. So go into your L1 and arrow up to go down to the function line. So that's when your cursor will be blinking down on that function line. Then from there, here's how you get random integer. Hit the math button. Math is on the left-hand side of your calculator. I'm opening my calculator here. It's for me, it's the third button down. So I think if you have a TI-84, it's the third button down. If you go over to PRB, or for some of your calculators, it says PROB. So it either says PRB or PROB. That's probability. That's your probability number menu. So then you go down to option 5. Option 5 says random integer. So random integer, and then enter what you want. So my lower limit, let's say my lower limit is 0,1. Let's say my upper limit is 28 if I'm looking at that hotel example. Then I'm going to pick 5, or no, it was 4. I'm going to pick 4 because that's the SRS that I want. That's the sample size that I want. When I did this, I got 23, 11, 15, and 14. Those were the random integers that it drew for me. It's going to auto-populate into your stat editor. Now, you don't have to do this stat edit piece if you don't want to. You can just do this piece, and it'll just put this list on your home screen. That's what I just did. I just did the piece where I hit math, went over to probability, went to option 5. I started at 1, I ended at 28, and I picked 4 because I want 4 samples. Then I want 4 things in my sample. Then I hit enter, and I got these digits, okay? Your digits might look different than mine. I've used my random number generator lots of times, and so mine is probably starting off at a different point than yours is. And that's a whole nother thing too. Your calculator will keep pulling random numbers for its entire life until you tell it to reset itself back to like its original, random number starting point, basically. So I've used my random number generator a lot of times. You maybe not have. So you might get the same list as somebody else did because you're both starting off using your random number generator at the same place. You both have never used it before. So it just depends. And that's another thing that we can do. When we're pulling samples for data in our class, we can purposely start our calculators at the same point so that we all pull the same sample, or we can purposely start our calculators at a different point so that we all pull different samples. So that's a whole nother thing when we get into sampling a little bit more that we'll do. If you want to sort that list so that it's easier to see them, it's not so hard when you're only doing 4, but sometimes you want to sort your data. We did this very briefly when we talked about box and whisker plots, but you can go to stat, you can go to option 2, and then you can enter L1 or wherever you put your data, and then it's going to sort them from like greatest to least. Least to greatest, not greatest to least. Sort A is least to greatest. Sort D, I don't know what option it is. Sort D, it's probably 3, option number 3. That's if you want to go from like Z to A. That's your Z to A sort. This is your A to Z sort. Hopefully that makes sense. All right, so now let's use a random number generator. If I use the random number generator on my calculator, I'll just do it again and see if I get something different. So I'm gonna go to, I'm gonna just do it on my home screen. So I'm gonna hit math, and then I'm gonna go over to prob. For me, it's prob. Then I'm gonna go over to, or I'm gonna go down to option 5, which is random integer. And then I have all those choices. So then I do lower is 01, upper is 28, and N is 4. So if I do that, I get a new sample. My sample this time is 26, and 12, and 5, and 13. Okay. So give it a try. Try it on your calculator and see if you can pull 4 of those random integers. So other random sampling methods, or other sampling methods, one of the most common alternatives to simple random sampling is called stratified random sampling. Strata are groups of individuals who share characteristics that are associated with the variables that are measured in the study. So if, let's say I wanted to poll our school about the seniors being able to leave campus, how people feel about the seniors being able to leave campus. Maybe I split my survey into strata, and maybe I poll 9th graders, and I poll 10th graders, and I poll 11th graders, and I poll 12th graders, because depending on what grade you're in, you probably feel very differently about seniors being able to leave campus for lunchtime. So, you can split your sample, you can split your population into strata. A lot of times we split our population into males and females so that we can see how it's going to affect a gender differently. A lot of times we can stratify our sample by age. So if we're looking at a population of people, but we want to see how it affects the ages differently, we can do that. So there's a lot of ways that you can split your strata. Stratified random sampling works best when the individuals within each stratum are similar with respect to what is being measured, and when there are large differences between the strata. So that's kind of what you're looking for. Like they may all kind of think the same thing within their strata, but they may think differently than another strata group. So we can choose strata that have similar responses within strata, but different responses between strata. Stratified random sampling gives a more precise estimate than simple random sampling. Another method, it says when populations are large and spread out over a wide area, we'd prefer a method that selects groups or clusters of individuals that are near one another. That's the idea of cluster sampling. So a cluster is a group of individuals in the population that are located near each other. Cluster sampling selects a sample by randomly choosing clusters and including each member of the selected clusters in the sample. So cluster sampling works best when clusters look just like the population but on a smaller scale. Cluster sampling is often used for practical reasons like saving time and money. So you could, if you go back to my example from Cub Foods, you could kind of call that a cluster sample as well. It was also voluntary response because I wasn't forcing people into it, but you could cluster sample, like if you wanted to take data on the whole state of Minnesota about something, you could cluster sample and use the city of Minneapolis, because there's a wide variety of people in the city of Minneapolis, and they're probably going to be representative of the state of Minnesota. Maybe not all the way, but depending on what you're collecting, depending on what data you're collecting, that's a way of saving resources, because it takes a lot of time to reach out to all the people in the entire state of Minnesota. But if you do it in one small area, sometimes it's a little bit easier. So that's cluster sampling. A lot of people say that there's bias that comes with cluster sampling, so you got to be kind of careful with it. But it can be used if you're trying to save time and money. All right, so that's our very first introduction with sampling methods. We're going to be done for now, and we will pick up with the rest of section 4.1 in our next lesson. So thanks for tuning in, and I will catch you next time.